back, no.
Okay.
Cool, you're cool.
The floor is yours.
Yeah, okay. Good morning, everyone. We are Group 1, Francis, Luik, Marina, and Tanya. And me and Luik are going to present our meeting. Just to remember, our clients are Heineken and IMAS. And the goal of the project is find a sustainable way to remove the phosphate from the groundwater. Well, the first experiment was sand filtration with cotton. To do that, we took a column, put cotton inside, took a beaker, and put in the beaker 100 milliliters of sand, put in the column, used daily water to clean the sand, and it starts to filter. But first, we measured the phosphate concentration before the filtration, and it was 2.03 milligrams per liter, and the legislation requires less than 0.11. Well, we have three results with three different samples. We used 200 milliliters of dry water to filter, and the final concentration was more than the required final concentration. So the first experiment didn't work. We thought that the cotton could have a big influence in the removal of phosphates. Then we tried the sand filtration without cotton, and again, it didn't accomplish with the requirements. It's bigger than 0.11. So we tried with compost, because in one meeting we discussed it with Yapa and Heine that it could work. Then we tried to put the only compost in the column, but it didn't work because the groundwater didn't pass through the compost. Then we tried to put a pump, and it was even worse because the air just compresses more the compost, so we didn't have any results for it.
After we have make a precipitation with iron-free salt. So first part we have create a precipitation with this solution. We have make it with powder of iron salt with 0.002 molar. And we see we have a precipitation with phosphate in the boiling water. And after we have filtrate in the sand filtration, and we can see we have not really good result after filtrations with phosphate about the legislations. So we can say it's a fail for this experiment too. After we have, we would like to make a limestone filtration, but we don't have limestone, so we have take powder of calcium carbonate and mix with sand in the column, which about 10% of calcium carbonate is 10 milliliters of sand. And we can see we have a good result of phosphate, but it's not really realistic because the powder have a lot of etchant surface than the limestone. So it's a good result, but not realistic in the factories. And for finish, we are trying to the resin part, which kind of resin, which polymer covered, which iron oxide. And we have very good result because we can see rainwater is really more yellow and it's really in color after filtrations of the resin. And we have a really good result after this. And I think it's a good way to focus on it for the project and see really what's happening.
And for the last experiment, we had a new sample of rainwater because the other ones like 3 or 2 weeks in the lab. So before filtration, the concentration was lower than the first one.
So now we are going really to focus in the resin treatment and see really what's happened on it, and if we can make it on the brewery. We are not more lab work because I think we have seen all of the pre-treatment we can make, and now we make the full diagram of each treatment work and see the costs about the current situation for the future situations.
And also study how we can recover the resin to reuse.
That's all.
Okay. Questions? Probably I'm going to ask all questions today. I hope not. You say you don't have to go into the lab anymore. Is that
For
correct?
the moment.
For the
Oh, not for the
moments.
moment. Okay. Because I can imagine that things like how can we recover the resin, and what do you mean by pre-treatment of the resin?
Yeah.
Before we can discharge it. So it will be the pre-treatment. We have brine water, and
Yeah.
we want to use the resin, so it will be a pre-treatment before we discharge it into the river. So we want to use it as a pre-treatment.
Oh, okay.
Doesn't mean the pre-treatment of the resin.
Oh, okay. No, that's what I understood.
Yeah.
Okay.
Like 3D they made.
Yeah. And with regards to the iron chloride, you had a quite a low quite low, but low concentration. Did you try other concentrations?
No. No,
Why not?
Because I think it's not really realistic. We need to have a limestone for seeds really available.
No, with the iron chloride, this one. I don't know whether you calculated the solubility product, because then you know how much phosphate will be left if you mix this with
Yeah, but I think we have
with phosphate.
We are not just phosphate precipitate in the solution. We have a lot of other solutions.
Oh, okay. Yeah.
Not
But-
just phosphate, but other.
Would it be problematic to use a higher concentration to try that, or?
Well, if you use higher concentration, then eventually it won't be sustainable because you use
Okay,
a lot of
so you use too much chemicals. Okay, that's a valid reason. Okay, thank you very much. Next group. Who wants to go next? Which group are you?
Group one.
Group 1. And you are group 2? Okay. Okay. Okay.
We didn't send it to our own meal. Because we have to open it.
It doesn't matter.
I would like it on Facebook. Well, yeah, that's fine. It's the easiest.
You can start.
Good morning, everyone. We are group 2. We're going to discuss our results. First, we will give a refreshment about our project, what the goal is. Then we will talk about the sand filtration, compost filtration, phosphates, calcium carbonate, iron chloride precipitation, and the next steps. Final and conclusion so far. And the refreshment for the goal, our goal is to remove low concentrations of phosphate of brine water of Heineken. We try to remove the low concentration of phosphate with sand filtration. We played with the amount of sand in a column, and as you can see, after the filtration, the concentrations of phosphate change with the height of sand. The lowest concentration is at 75 millimeters of sand. This is probably caused by cotton, because we had a layer of cotton under the sand, and probably the cotton took up some phosphate. But all these concentrations of phosphate are too high, because we need 0.1 milligrams per liter of phosphate in our final water. The second medium we tried is compost. As the previous group said, Jappe gave us a hint to try compost for filtration. So we tried with different percentage of compost mixed with sand. We tried 2% of compost and 5% of compost. As you can see, the 2% of compost has a higher concentration than the 5%.
So it correlates to the fact that the more compost you put, the more it removes the phosphate. But again, you don't want to do it too much, because the other group had the experience of getting the column blocked. Yes, so we just put a little bit and it's still removed, but not enough.
To have the limit. And the second medium we tried is Phosphates. Phosphates is a granule that's used in aquariums to remove phosphate.
It's actually a commercial option.
Yeah, to remove it. We couldn't use the results of this, because the water we used was not usable anymore, because it was out of the fridge for too long, and the concentration of phosphate was changed a lot, so we can't use the results at the moment.
We're planning to do it after the vacation. We'll have again another experiment. We got new water. And well, the calcium carbonate, as the previous group said, the best thing to do is to use limestone, because the phosphate is bonding to the calcium, so every kind of medium that has a high amount of calcium in it will bond to the phosphate. But we don't have limestone, so we only have the powder, so calcium carbonate. We had some problems and issues with this, because it closed. It's a very, very fine powder, and it just made a almost impermeable layer on top of the column, so the water didn't pass through. I think we just put too much. We also used 10% of calcium carbonate. So for our experiment, it was too much. It didn't really work out.
The results of this experiment were very good. It was below detection level, so it means it was below 0.1 milligrams per liter.
So this
works.
Yeah. Yeah, so we also did iron chloride precipitation, so it works on the same principle that phosphate bonds to either, it bonds good to iron or calcium. So with iron, we used iron chloride, and well, we got this result, so 0.7 milligrams of phosphate per liter. It's again too much because we need 0.1%. Okay, and well, we actually tried it twice, but the first time we tried it was with too much iron, and then we got a very orange concentration. This is what you saw. But apparently the concentration of iron was too high, and we didn't measure it correctly. So the second time we did it good, and this was the results. So as we said, for the vacation, after the vacation we will try with the commercial filters. So is it with BioAqua? We got a sample from this company, and it's specifically for removing phosphate from water, and we are expecting to have good results. Same thing with Phosix, and yeah, we have one more slide, I think. So this is our conclusion. So far, it's halfway because we have to do a few more experiments. But we are thinking, because the problem with Heineken is that they discharge huge amounts of water. So biological treatments are a bit more complicated to reach, almost 100% removal. That's what we are aiming for. And because of such high amounts of water, we think that maybe using the chemical option is more feasible because it can remove very high amounts. Or those man-made products that are especially for it, better than the sand or other biological options. So that's for that.
Thank you.
Any questions? Come on, guys. Nothing intelligent to ask? No? Let's say it's Friday morning, that's the reason why. I have lots of intelligent questions. Sand filtration, I saw in your experiment that you changed more than one parameter at a time. So you changed the amount of sand, but also the amount of water, and with and without cotton. So it's difficult to draw conclusions if you do not change one parameter at a time. That's something you have to take into consideration, I think, when you do the experimental setup for the rest of the experiments. And for the compost, did you try to add more compost?
More than 5%?
Yeah.
No, but there was also one more problem, that it colors the water.
Okay.
So this is, and then it probably needs to have one more step before discharge, and Heineken wouldn't be satisfied with this.
Yeah. Okay. And in the final slide, you showed the removal capacity. And of course, it's easier to compare if you use the same unit everywhere, because some are in milligrams per liter and other in percentages. So it's better if you express removal capacity as a percentage everywhere, I think.
It's not
Yeah?
a percentage, it just means for compost.
Yeah, we have
Just compost percentage.
we have two types of compost filtration. One with 2% of compost.
Oh,
and one
I'm
of
sorry.
5%.
Oh yes, you're quite right. So it's everything in milligrams per liter,
Yeah.
but still, do you have exactly the same beginning concentration? Because this doesn't say anything. It doesn't say whether the final result is acceptable, yes or no, or how much it removes. So I think it's better if you use removal capacity as a percentage, or doesn't that make any difference?
Maybe it's better.
It's better.
Yeah. Okay, those were my remarks. Thank you. Group 3, please.
Well, start. Two of our group members today couldn't be there. Thomas is on his way to Russia, and Sylvie is sick today. So unfortunately, we two have to make the PowerPoint presentation ourselves. For some of the topics, like of the experiments, this will mean that we don't have like the deepest explanation of the matter, as the specialists are missing today.
They were in the lab.
Yeah, like we also, but we divided the topics, and they were specialists in some part. So yeah, our project is about the removal of humic acid from the wastewater of Ecoson. Just to recap, to get it back into your memory. We did a literature research. We chose some techniques that we wanted to test in the laboratory, and we basically came up with those three, which is removal by eggshells. The principle is absorption to calcium ion-enriched material, because humic acid can bind to calcium. Then we have electrocoagulation, which works basically with the charge, and then activated carbon as a measure of filtration. I think you all know activated carbon filtration. What we're going to talk about is basically what we did, the experimental setup itself, and then the results of those. Well, to begin with, the absorption via eggshells. Like I said before, humic acid is an acid, and it can form ionic bonding with the calcium carbonate, which is in the eggshells. We read in the internet that this is basically a very, very efficient technique, so we decided to try it. Well, basically to prepare the experiment, probably not very interesting for you guys, but we had to clean the eggshells and then smash them into powder or smaller pieces, and then put it in a column and basically run column tests on those. So we had, all in all, we had five experiments we did. First was like a trial experiment, just a column, 15 grams of eggshells, 100 milliliters of wastewater sample, and we always used the one, like we had different samples from different points, but in the end we used the one they would discharge into the water, as we thought that the humic acid concentration should be highest there. Well, then we did the same column filtration test, but this time we didn't lower the pH, what we did in the first time, because we read the lower the pH is, the better the absorption. That's what they said in the literature. But we didn't have any positive results for the first try, so we said, okay, we just try without lowering the pH, also because it would be more feasible for Ecoson themselves to do this, as you don't have to change the pH of the huge wastewater stream. Then we did another, also column filtration with a different type of wastewater from different points, where we basically, the assessment was it was very dark, so, and as the goal is to remove the staining from the water, we said, okay, we're going to try it with that. And then finally we did 2 batch experiments with 100 milliliters and then with different stirring speed and different times. Okay, so yeah, well, the table got missing, that's in the background usually. Well, to tell you in a nutshell, basically the experiments we ran with eggshells didn't work. What we did is we took the pH before the absorption. We took the we took the absorption, which we measured with the spectrophotometer. We took it before and after the absorption. We compared it. This table, unfortunately, is not complete. Like we have all, like the other values, but due to the sickness of Sylvie, got messed up a little. Yeah, so it's not really nice to see now in this table, but in the end, the outcome of humic acid absorption with eggshells, it doesn't work. We had no significant removal, and even the removal, like the absorption of after running the experiments, it would vary quite a lot. Okay.
So for the electrocoagulation, as we said, that it's Thomas' part, so I will try to explain how I can. So it's like it will coagulate the humic acid and all the organic compound in our sample. So we will put like a voltage and intensity and the same time with different plate of iron. Then with the current it will coagulate the.
I don't know if you can see what the picture shows, like from close. Basically a carton box. This is our wastewater sample, and then those are electrodes which are put into the water with the current, and then the principle is that the humic acid absorbs to the. No, it coagulates.
So then, for the result, we found that it worked pretty well. So after several treatments, you can see that the absorption of humic acid is reducing. So it cleaned very well. So he made it like on the most dirtiest one samples and the cleanest one. Yeah. This one is the dirtiest one, I think. This one is the cleanest one. And then as you can see, the absorption after several treatments is reducing, so the amount of humic acid is also reducing. And you can see the color is changing also. It's the main objective of our experiment. And you want to try like on a different voltage because you made it like on the same voltage, so you want to see if the voltage have an influence on it. So we'll do it like next week, I think. And for the following activated carbon, basically it's an absorption. So I tried with a Conan and with a batch process, but basically with the Conan it didn't really work, so I only focused on the batch system. By changing the time and the amount of humic acid, following activated carbon to see if there is an influence on it. So I started basically with the same amount for the 3 samples to check if it's worked really well and on which sample is the best one. So after I found like it's really, for the 2 first samples, it's really take a lot of time to filter it. So I decided to focus only on the cleanest one at the end of the process for Nicholson. So I changed the amount of activated carbon from 1 gram or 1 milliliter to 0.1 gram. And as you can see, the absorption also is reducing. Then after, I did it with the same amount, but not with the same time, and it's also reducing. So I think now I just have to calculate the removal rate of humic acid and compare it to our calibration curve. We didn't have any picture of it, but we made a calibration curve with pure humic acid in the sample, and we'll combine it to check our concentration of humic acid in our sample.
It's also not like what we still need to do is to compare the absorbance values and then calculate it into a removal efficiency. But we haven't done it.
And I also need to try to find a solution if we can reuse powdering activated carbon with humic acid. Otherwise, it won't be really.
And then also to recap, basically what the results of or the conclusion of our experiments is that activated carbon has a potential of being used. The same with electrocoagulation, and eggshells. They basically we dumped this idea. What now obviously needs to be done is to see or to look into the feasibility of using those processes with huge quantities of wastewater.
Okay, thank you.
Question?
Anybody questions?
Because activated carbon can remove almost any kind of pollutants from any kind of strain, right? We didn't try it on our experiments, but could you tell what are the negative things? Nothing. Like cost,
for us.
like in cost-wise?
Well, it's maybe, it depends on which type of equipment.
For us, the problem is that.
You can brush it, you can eat it.
Yeah, but then what do you do afterwards when you...
Yeah, that's the main problem of our carbon activity because they want to maybe recover the humic acid and reuse it, like sell it on a commercial way.
The carbon?
No, the humic acid,
No,
but
what do you do? Because
but-
well, yeah, maybe we can.
but
The idea is now basically that, well, first of all, we thought, okay, maybe it's possible that the humic acid absorbs to the activated carbon, and then it might be possible to recover it.
Yeah.
But it's just not feasible how to get the humic acid off the carbon in the end. So the idea basically is now to say, okay, we just use the activated carbon with the humic acid combined, and we sell this as a fertilizer. What we still need to do is looking up if it's actually by law, if it's possible to do this. Also because you said there's a lot of things binding to the activated carbon, can be also heavy metals and stuff like this in there. Yeah, so this is basically subject of further research we have to do.
Yeah. Other questions? I had one small remark. The first slide you showed with an experimental setup for the eggshell, that's not a good way to present
Yeah,
your too much information, too small lettering.
Yeah, yeah.
And also in one table you said adsorption value, but I think you meant absorbance, which you did write in the last slides. So make sure you don't make that mistake in your report or in your final presentation. What do you mean by the number of treatments in the coagulation experiment? One treatment is 10 minutes or something like that?
no, this one, right?
Yeah?
Like, he made this process during half an hour,
Yeah?
and then he filtered it
Yeah.
on cotton, and then the filter he reused to remake the same experiment.
Okay.
So it will be the second treatment. So as you can see there, it's like he made
Yeah.
like 5 treatments.
But might it
So
also
5.
be an idea to say, okay, we're not going to filtrate in between, because of course that's a very work-intensive kind of thing to do, and we just do it for 2 hours at a time, instead of 4 times half an hour. Might that be something to look into?
But after the coagulate will kind of block the plate, so it
Oh,
won't
okay.
really-
So you have to remove
It's
it.
like half a centimeter between each plate, so with the coagulant
Okay.
it won't be very efficient at that.
No, that's a good reason.
Which we also have to take into consideration, obviously, about feasibility.
Yeah.
I mean, if they have to clean the
Yeah, filtrate every
plates every
time.
day, it's not feasible.
Yeah, there might be other solutions to find for that, but yeah.
So we thought that we can make like several batch with several reactions, like for the first treatment, second treatment.
Yeah.
Then it will be like.
Yeah. And one last question. You said the activated carbon, it didn't work in the column setting. Why not?
No, it works, but like it took really a lot of time because it's powder, so it
Yeah.
will block the column.
Yeah.
So we decided that we don't use it because, for example, to filter it like 100 millimeters, it took like 4 hours. So
And you don't have granulated carbon.
Yeah, the other group actually did the experiments with
Okay.
which
Okay.
I
We'll
think
hear
I'm
about
going to
that.
tell about the results.
Yeah. Okay. Thank you. Group 4.
So Billy and I want to go back to France, and we just found like someone who to the
Yeah.
web. Do you think it's possible to do this lesson in gym?
When do you have to leave then?
The guy leave at like 11.
I'm sorry?
The guys spread at 11:50. So
At 11:50. But you still have to do your presentation, or not?
no, like Manu and David did it,
Yeah.
and now it's the slides.
And then who's going to leave?
Billy and I.
Yeah. It's not up to me to decide. I'll just write down that you have halfway the presentations, and what the consequences will be, I cannot predict now. I'm not going to say it's okay. Yeah? It's up to you.
we are working on the same project as the group that presented the results before, so it will be quite the same. Okay. We are also working on the removal of humic acids from the wastewater of Ecozone. And yeah, so first the goal was we carried.
Yeah, well, we had this. Well, we also used actually the same techniques that they did. The removal of the eggshells and removal with the carbon. The only difference between our two experiments is that the other group only used the fine powder carbon because we had it in advance. But we had contact with our company and they provided us with their carbon from their supplier, which you can see here. So it's granules, it's very thick, like half centimeter diameter, for example. So we used both types of carbon, and then we also tried to grind it because, well, it didn't turn out. It turned out that this is not really efficient, so we grinded it. So we had something in between, like a mixture, kind of.
Yeah, so first experiment we tried with the carbon was the batch, in the batch system. It's pretty simple concept. You have a beaker with the wastewater, and it was like 100 milliliters. We dropped in 1 gram of carbon, then you stir it for, we choose a time of 40 minutes. And at some intervals we took some samples, and these are the results we got. These are the results from the powder carbon of the school. Yeah, in the graph on the left you can see the efficiency in percentages, which is easier to look at. See that at 5 minutes it was at 40%, at 10 minutes it was at 60, at 30 minutes it was 63, 64. Yeah. Then we tried the same experiment with the carbon from the client. And first we tried it with in the granular version. We saw that it wasn't really working, so we said, okay, let's try and grind it. And after grinding it, this is the result. I don't know why here it shows at 5 minutes it was minus 15%, probably something wrong, because after you take the sample, like at 5 minutes, the wastewater is black because it's full of the carbon, so you have to filter it. Maybe the filtration went wrong. Sometimes the very fine particles of carbon go through the filter. And with this carbon, we saw that the maximum efficiency was after 30 minutes at also 63, 64, 62.7%. So pretty much the same. Also, the same as the other carbons that maximum efficiency, it's always at 10, 15 minutes and 30 minutes. Okay, then what do you have?
Do you have anything to
No, that's all.
As the other group, we also did the experiment with the eggshells. Some small difference that the client asked us to do, because since we're doing the same technique, we considered the time we used in the batch system. We took samples 5, 10, 15, 20, 30, 40, 50, and 60 minutes. The amount of eggshells we did first as the article we found with 5 grams, but the results weren't very positive, so we tried with 15 grams and 30 grams. And we took account the pH, even though the optimal pH is about 6. And well, the water was about 8 from the wastewater. And for the company, it's not very good that we have to lower the pH and then increase again. So we left the sample with the natural pH of the wastewater. As you can see, the results were not very positive for the technique. In this case, it didn't. The removal of the humic acid didn't go further than 30%. Even if we left for more minutes, it didn't make much change. And here you can see this is the natural
wastewater sample, and this is after the batch system. And we have the issue that, as you can see, the water is stained, so the color is also natural. And this was one of the reasons Ecosone asked us to try to find out a way to remove the humic acid, to remove this color, but it got worse. Now it's even more stained. And even with the turbidity, after filtering the syringe, it doesn't get better. Even filtering, the water is still a little bit stained and white.
Well, and then we had another experiment with the filter. Well, like I said, we use different amounts, different carbon in that filter. So the granules, the grinded version, powder, and a mix of the granules and the powder to see whether we have, like, what is influencing on the efficiency of the filter. And, well, we made different setups for the filter with different heights. And we actually filtered it like every time 100 milliliter sample, and we measured the pH and the adsorbance before and after to actually determine the efficiency of the filter. And this is an experiment where we used only the granular carbon, and I made 30 centimeters of the filter and let it run once, twice, like 4 times to actually see, how the adsorbance efficiency decreases after time, because, well, the filter, you use it several times. And, well, as we can see here, first time it was 40, and then it dropped about 50%. And this is actually the color change. This is the first time, and this is the fourth. So, well, kind of we see it's not really, the granular are not working really well, because even though we remove something, but the water is still colored, so this is not what we want. And then we had the grinded version, and we used different filter thicknesses, so from 0.5 centimeters to 3 centimeters. Well, and we see that the efficiency of removal increases with increasing thickness, and but also the time needed for the filtration increases a lot. So, like for 0.5 centimeters, I think it took us 30 minutes, and for 3 centimeters, almost 1.5 hours to seep through. And we always made Duplo experiments to actually make an effort in the end. And then I compared, we also did the experiment with the powder with 1 centimeter, and I compared the results from the grinded version to the powder version. Well, and we see that the removal efficiency is almost 50% more for the same thickness of filter. Yeah. Plus, here we used half of the amount, like in grams of carbon. So, well, powder is actually the best. Well, we had some issues during that experiment. For example, because when we filter something and the acid gets removed, pH rises. So normally, I would assume, or everybody assumed that, well, the more you remove, the more the pH increases. This was totally not the case, because I don't know why. So apparently the pH change is not related to removal, which we still have to find out why. Plus, we had differences in the Duplo experiments. For example, this also shows the pH of the sample, and here the pH decreases, and here it increases according to the filter. So we also don't know what went wrong there, so we have to redo that 3rd time. Well. It's again me. Okay, well then we had another filter with the eggshells, because we thought maybe we tried out, even though the batch system did not really work too well. And this got proven, so we've made the filter once with these centimeters with the normal sample, and the removal efficiency was 1%. And then we dropped the pH with HCl to 1.5, and then the removal efficiency was 35%, which was an improvement. but we can see that the acid completely degraded this filter. So I don't know if you can see it, but it drops, like it was 3 centimeters, and after the experiment it was lower. And also, well, this was on top of the column because this stuff floated to the top. So we decided it's kind of not working. Yeah, well, this is the first thing. And plus, it's not sustainability friendly because we used HCl to drop the pH. Well, the carbon powder works the best, takes the longest time, so we need to have to find a solution for that.
Okay.
And the future plans is we're redoing the carbon experiments with different settings for the powder. We find out more about recovery methods because this is actually what we want, that Ecosun can sell it further. And we're gonna test another experiments at like another time. Zeolites are stones, kind of minerals, and they can extract humic acid as well.
Okay. Thank you. Any questions? I was wondering, you worked with eggshells. Why not just use calcium carbonate?
Because Ecosun is a company who has animal products, so they already have eggshells on the side.
Okay.
So it would be actually very economic for them to use them.
Okay.
But
it doesn't work. One remark, in some of the graphs you didn't add the units to
yeah, I couldn't find out
the
how to do
axis. Okay, but make sure you do that for your final report. Well, you said, well, the pH doesn't change with the removal efficiency. Do you expect that to be the case? Why would you expect the pH to change? Or do you not expect it to change? Or why are you so interested in this pH?
Well, because, well, normally when you remove acid, pH rises. And after the treatment, Ecosun discharges the water into the river. And if we discharge water of the pH of 10, we're like a very high difference. So it's not good for nature.
Yeah.
Otherwise, we need techniques to decrease it again. And
yeah. Okay, that's clear. Thank you very much. Group 5.
Yeah, it's not drawn. You draw it and then we did like make it fit.
Ik denk wat wij doen. De zanden naar gelopen te doen.
Ik denk jullie hebben veel last van dat kijken met shit wat eruit komt. Laten we dit wat? We hebben het net over wat gemaakt.
Ja.
project, VFA production from primary sludge. To give a short introduction again about the project. We are producing VFAs from primary sludge from a wastewater treatment plant of Waterschap de Dommel. The setup for our experiment is like this, because we use 3 different conditions to see which VFAs we can produce. First of all, we look at the temperature. Temperature of 50, 20 and 25 degrees. And we use a pH of 6, 8 and 10. Next to that, we look at the retention time of maximum of 9 days. Because, well, approximately 9 days is when you get the maximum amount of VFAs from the sludge. These are the batch reactors we are using. You can see that they're in a bath, so we can regulate the temperature. Next to that, they're also mixing, because we found out from literature research that mixing increases the amount of VFAs produced, and it also increases the speed at which they are produced. Here we see the COD. COD is important for the production of VFA because it uses COD. But our results aren't really clear because also the machine wasn't working very well. We're also still waiting for the results of our sludge before it was used.
Which machine wasn't working very well?
The Hachlange
Okay.
machine. And we're also still waiting for the results for the sludge before we did the experiment, so we can see the differences that the experiments made.
The results of sludge?
The results of the COD measurements from the sludge before we started experimenting.
Okay, and where do you need to get those from?
The other group was able to use the machine, so we will look at their results because they use the same sludge. The total suspended solids are also important because for the production of VFAs, the total suspended solids are used. So we would expect that the solids decrease in time. Well, we can see here day 2 how much solids there are. And you can see that the results aren't really giving a clear view that it's decreasing. This is also because we have very low amounts of total suspended solids, and also because the sludge has big particles in it which can be taken up by a pipette. So these results are a bit inconclusive. Also here you can see the same, because the time of days you would expect that it decreases. You can see that here it doesn't even decrease. There a little, and here also a little decrease is shown of the TSS. The most important part of our experiments are the GC, the gas chromatography. With this we can see which VFAs are produced, and we can see how much of which VFAs are produced. So that's our next step. At the moment we're preparing the samples, which are prepared by first acidifying the sample to a pH of 2 with use of nitric acid. Then we add a ether and mix it for 10 minutes. This separates the water from the ether. We take out the ether because the VFAs will only be present in the ether, and we use the GC to get the line of how much VFAs are produced. We have some problems with the pH, because as I showed in the experimental setup, we use a pH of 6, 8 and 10. For this we use the buffer solution, so that the pH remains at the correct value. But we have seen during experiments that the pH is decreasing. The pH of the sludge normally is 6, and we can see that it's also decreasing towards 6, even below 6. So the pH which should be 10 is approximately 8.2, 8.3. Which should be 8 is just above 7 and 6 is just below 6. So this is something we have to keep in mind when we look at the results. Thank you for your attention.
Any questions?
Yes. For the pH of 6, did you also add a buffer, or?
Yes, we did.
And did you also measure the pH in time after the?
Yeah, every time we took a sample for the retention time. So after 3 days, 7 days, 8 days, we also checked the pH, and we could see that the pH was decreasing. During this time.
Also at 6.
Also 6, yes. That went below 6.
Okay.
Can you show me the first slide again? Yeah, because I am totally unaware of what is your goal and what you're going to do.
Of course, yes. I
Okay.
assumed,
Can you explain to me?
Of course. Well, we want to produce volatile fatty acids from primary sludge. So to do that, we will make different batch reactors, which are anaerobic. And because of the bacteria in the sludge, VFAs will be produced.
Okay. And are the bacteria present naturally, or do you have to add them?
No, you don't have to add them.
Okay.
They're present in the sludge.
Okay, that becomes clearer. Why are you measuring COD and TSS? What's the interest for COD and TSS?
TSS can be a good parameter to see if VFAs are produced, because to produce VFAs, TSS are used. So
TSS is total suspended solid.
yes, they are.
Yeah?
Our client mailed us to say we would like you to measure TSS because TSS are used when VFAs are produced.
So should the TSS increase or decrease when you produce VFA?
It should decrease.
Okay. And why do you measure the COD?
Well, maybe my group members can explain that better, because it's not really my part.
COD is used to generate viral
Yes.
organic matter, so we want to see, can we relate the amount of VFA produced and COD decreasing. So we want to we want to get a nice curve where we can see where VFA is increasing and COD should be decreasing.
So both TSS and COD are a measure for how much sludge is in your sample, and that should decrease when they are digested to become VFA. Is that the way?
Yes.
Okay. Yes. And why do you change the pH? Is there any?
You mean the different kind?
Yeah.
Because our client wants to know at which pH the most or which VFAs are produced. So
Okay.
that's the reason.
Okay. So as you can see from my questions, there are a lot of things that are not very clearly explained in your presentation.
Yeah.
So make sure you do that a bit more
Yeah,
elaborate
there
the
were
next
some,
time you do
yeah.
it. Oh yeah, and there was one table where you said, well, there's not a clear relation between pH and lots of other things, but we cannot deduce that from this table because it would need a lot of time to study all the numbers to see whether or not there is a relation. So if you want us to understand that there's not a relation, you have to present it in another way than this, because for us it's very difficult to see this from the table. It's too complex to read in short time. Okay?
Yeah, I just learned the last row, but
Yeah.
I understand.
I have a question about the
Yeah.
temperature. You're working with bacteria.
Can you please reduce the chatter a bit? Yes.
No, because they're working with bacteria, and he said that you're trying it with 15 degrees, but usually bacteria needs warmer, so why do you even try to measure it in 15 degrees?
It's basically to see the difference. It's really, because we know from literature that probably 15 is indeed not going to produce a lot of VFA, but we want to see the difference, so that's why we choose it.
If you have a higher temperature, it also maybe means that you have to heat your
It's also
water
more
more, which is of course not very energy efficient. So, because what is the temperature of the sludge when it leaves the?
I think it's just cold. It's probably below 15.
So it would be nice if you can do it around normal temperatures.
Yeah.
Okay, thank you. Group 6. Oh yeah, I don't know whether you want a 5-minute break or 10-minute break to get some coffee. I think we have a lot of time. Sorry about that. Sorry. I see some people leaving, but take a 10-minute break.
Practice.
Sorry.